Now in this video, I want to discuss one additional means of evaluating projects. It's called the payback period. Now we've covered three project evaluation techniques: present worth analysis, annual worth analysis, and internal rate of return analysis. All three of those incorporate the time value of money, and those are the appropriate ways to evaluate projects. However, many companies, especially small companies and startup companies, utilize a technique called the payback period to evaluate a project. And even larger companies will calculate the payback period just as a means to test whether the project meets some of their criteria. So what the payback period is simply it's the time required for a project's profit and benefits to equal its cost. So the idea is, how long does it take to get your money back? And I work for a small company right now, and money is an issue. It's not a huge issue, but it's an issue. It's not like working for Exxon or for Apple or for Google, where money really isn't an issue. And so, like, worst case, when do we get our money back when we evaluate a project? And so they like to know what a project's payback period is. And it's an approximate method because it ignores the time value of money. So, and it also ignores everything after the payback period. So if it takes 2 years to get your money back, and that's your only criteria, you may not be interested in what's happening after that second year. Or what if your payback requirement was a 3-year payback, and if you didn't meet that criteria, you ignored everything after that, you didn't do the project. And years 4, 5, and 6 had 10 times the cash flows over the first 3 years. So when we use one of the first three methods, present worth, annual worth, and internal rate of return, if we do the method properly, we will always come up with the same conclusion. We either accept the project or reject the project. With the payback period, that may not be the case. We may have a good project from a time value of money perspective, present worth analysis perspective, but it may get rejected because it doesn't meet the criteria set forth in the payback period method. And usually the payback period is measured in months. And as I said before, it's very common in companies that are startups that are very short of money. And many projects with good payback periods also look good on other measures. And what's a good payback period? It's a good payback period 2 years, 3 years, 5 years. I do know my company, if it has a project that has a payback period greater than 3 years, we look very hard at the present worth because we are a smaller company and we look very, very hard at the present worth. So let's look at an example here. Okay, so we have two projects. We have project A and B, and project A has cash flows of $200 in the first 2 years and $1,200 in the last 3 years, but it only costs $1,000. And project B costs $2,783, and it has cash flows of $1,200 per year. So which one is the better alternative? Well, if your only criteria is the payback period, it looks as if the second alternative is better because its payback period is 2.33 years. Now note that we're using annual numbers, but we're using decimals for the payback period. That is very typical. Payback period is not typically done in whole years, even if the analysis period is in terms of years. And sort of the concept is that that you're going to be receiving cash flows throughout the year. And so this is a decent measure, is basically 2 years and 4 months, or this one's 2 years and 6 months. Not significantly different, but if this was your sole criteria, you would pick alternative B. Maybe it's a better project on an internal rate of return or present worth basis. Maybe it's not. If we were to do this project, we're going to compare two projects. They give you the same benefit of $4,000 a year. However, machine A costs $10,000 and has no salvage value. Machine B costs $15,000 but has a salvage value of $9,000. If your sole criteria is to minimize payback, you would pick machine B. Now let's look at this and let's evaluate this. So let's set an interest rate, and let's just make it 10%. And this is just an arbitrary number. And we have end of period, and we've got a 5-year analysis period, right? And we've got alternative A, and it's going to cost us $10,000, and we're going to save $4,000 per year. And the present worth of alternative A is going to be P equals F over 1 plus I to the N. Let's get that right. Okay, so at 10%, the present worth of A is $5,163. The payback period and this is an easy calculation because the cash flows are constant, is going to be 10,000 divided by 4,000, 2.5 years. Okay, now let's look at alternative B. Okay, we're going to spend $15,000 up front, and we're going to get $4,000 a year. But in the 5th year, we're also going to recover We're going to sell this for $9,000. So we're going to get $13,000 in year 5. Okay, so present worth of B these numbers look strangely similar, is a little bit higher. Now the payback is going to be 15,000 and you're getting 4,000 a year. So the payback period is 3.75 years. So what's the better project? I can't tell you what the better project is. It depends upon your interest rate. Well, what if your interest rate is 15%? Well, at 15%, it looks like alternative A is better on a present worth basis and on a payback period basis. So an interesting question to ask would be, at what interest rate, what is the minimum interest rate for alternative A to be better than alternative B, both on a payback period and on a present worth basis? So the difference in present worth equals this minus, oops, let's justify that, equals the present worth of A minus the present worth of B. So at 15%, it's $525. The point where it will be exactly the same is when A is better on both. So what we can do is a goal seek. And to do that, we go into data mode, what if analysis, goal seek. And we want to set this value here, the difference in present worth, to 0 by changing the interest rate. And we find out that at 12%, the present worths are exactly the same. So at interest rates above 12%, choosing the payback period is consistent with the internal rate of return method. At interest rates below 12%, choosing the payback period is inconsistent with the choosing interest rates below 12%, choosing the payback period is inconsistent with the present worth method. Well, what's the right answer? It just depends on your company. Most companies will evaluate projects on present worth or internal rate of return basis. And this is a good number just to know, because it implies a little bit more risk, the greater the number. Even though this is a better project if interest rates are at 10%, the numbers out in the future have less reliability. And so it implies a little bit more risk. Sorry about that delay. So this example right here, this shows the numbers that I just put together in that spreadsheet, which I'll post on Canvas below this presentation. So if we were to consider a project that costs $20,000, saves $8,000 the first year and $6,000 each subsequent year, After 1 year, we still need to recover $12,000. After 2 years, we still need to recover $6,000. After 3 years, we still need to recover $4,000. So the payback period is going to be 3 years plus the additional $2,000 we need to recover. And this is the cash flow in year 4. So it's unfortunate that the example has the cash flow in year 3 and year 4 together, but this is 2,000 out of this year 4 cash flow. So 3.5 years for the payback period. Now there's another animal that is utilized, and it's called the discounted payback period. And this is kind of like a break-even point, but taking into account the time value of money. And this is, in my view, a much better method to evaluate a project because it incorporates the time value of money. However, it still ignores the cash flows after payback. So if we have these two cash flows, and let me take this out to another example. I think I can use the same headings here. Okay, so let's look at alternative A first. So we've got minus 10,000, and then we have 3,000 a year. Okay, so this has got a positive present value. The undiscounted payback period equals 10,000 divided by 3,000, 3.3 years. Okay, now let's look at what we have here. Now we have the unrecovered balance. Okay, so this is going to be minus, right, when you make your initial investment, it's $10,000. Now the unrecovered, and this is going to be the discounted balance, right? Because you can do the same thing with the undiscounted balance with this column right here to come up with this number here. So this is going to be the prior period plus this amount right here. And we drag that down, and it should end up with the same as the present value. So what happens is when this thing flips, and you can write a smart you know, we can say payback. And if it's negative, it's no. So now this thing is flipped, right? And it's flipped from negative to positive. So the payback period is, and you can, this is kind of manual, but you can do it. You could write, you could solve this with if statements, but I want to demonstrate this. So the payback period is going to be between years 4 and 5. And so we're going to, it's going to be 4 plus, I'm going to make it a negative because I'm going to flip that sign. Actually, I'm just going to subtract that. We need to recover 490 out of 1862. So 4.26 years. Okay, so then we can do the same exact thing. Now we can do the same thing for alternative B. Let's see, we're going to invest 12,000. We're going to have 3,500. 3,500 per year. It's got a present value of 1267. Oops. Undiscounted payback is going to equal 12,000 divided by 3,500. 4.8 years. That doesn't seem right. 3,500, not 2,500. 3.4 years. Okay. See if I can do a copy here. So that just basically the unrecovered balance, payback, no, 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 yes. And what we're going to have is the same thing between years 4 and 5. So this is going to be 4 minus the 905. And we're going to recover that out of 2175. 4.42 years. So I guess by present worth analysis you would pick alternative A. By payback period you would pick alternative A as well, but they're not significantly different. But I'm sorry, alternative A by discounted payback period. Now you notice that the undiscounted payback period is less than the discounted payback period. Unless you have a really unusual situation, which I really can't think of right now, you will always have undiscounted will have a shorter payback period than the discounted payback period. So these numbers are off at the second decimal. They used the end periods function for doing this. The end periods function calculates the number of periods. It basically calculates the payback period at a given discount rate. I don't like using the end periods function, especially for calculating the discounted payback period. However, you can do it. I like doing it. call it the brute force way, the way that I showed you. So what I've shown you in this video is another method to look at projects. It's the payback period. I believe the better methods include the time value of money, and that basically means that I think the discounted payback period is a better method than the undiscounted payback period. However, in industry, I have rarely seen this method, the discounted payback period method, used. But I see the payback period, the undiscounted payback period, used all the time.